All right, so geometry basics. First, I just want to mention about how we name line segments. So, like the most basic example of this would be if you have a point A and you have a point B, and then you go and you connect these 2 points with a line segment. Basically, that line segment, this line segment can be called AB. So because it connects these 2 points, one of the points being A, one of the points being B, the line segment that connects it can be called AB. Technically, I think somebody could also call it BA, but maybe AB makes a bit more sense because it's alphabetical. We could just think about this as a point A and a point B and a point C, point D, point E, point F, point G, point H, point I, point J, K, L. And at the end of the day, these points are being connected with line segments. So this would be line segment AB, line segment BC, line segment AC, line segment DE, EF, DF, GH, GI, HI. We have line segment JK, JL, KL. So nothing too crazy here. I want to start in the most introductory way, which is just we can at least give these sides of any triangle a name, right? So we can say, oh, that's side AB. So there's one thing. Another thing is just a vertex, plural vertices, is a point where 2 or more line segments meet. So, for example, see how there's a line segment AB and a line segment AC meeting at this point? So that means point A is a vertex of the triangle. Vertices are basically corners. So all of these, B is a vertex, C is a vertex. So we can call all of those things, each of them are, each individual one is a vertex, but plural vertices. So it's just, plural versus singular. But at the end of the day, these vertices are just corners. Just basically, you can think about each of these corners as vertices. D is a vertex, E is a vertex, F is a vertex, and so on and so forth. So besides naming side lengths, we can also be really specific about how we name angles. So if we look here, there's these 3 vertices. We have line segment AB, line segment BC, line segment AC, but you can also see where the lines meet, an angle is formed. Where the lines meet, there's an angle formed. And oftentimes we can use the Greek symbol theta to say, oh, well, that's theta 1, theta 2, theta 3, or something like that. We could just talk about it using a variable, but we can be really specific and point out that to make this angle, we have to go from BAC or CAB. So we can call it angle, kind of like a little triangle thing, angle BAC or angle CAB. BAC or angle CAB. So with that vertex being in the center, the vertex or the corner being in the center of our three letters. So this angle, we would call that ABC. Angle ABC, because we go ABC, or it could be angle CBA. Angle CBA. This angle could be called BCA, angle BCA, or angle ACB, angle ACB. Any of these other ones is going to work exactly the same. Three different vertices, and there's an angle at every vertex. I can talk about this angle as angle EDF or angle FDE. This angle we can talk about as DEF, angle DEF, or angle FED. This angle we can talk about it as, or we can call it DFE, or angle EFD. So, and the other ones would work the same. This would be angle HGI, HGI, or angle IGH. So, GHI, angle GHI, angle IHG. This one would be angle GIH or HIG. So I just wanted to go over that because I think that's like geometry, like fundamentals, like beyond trigonometry, beyond anything like that, but just being able to name an angle specifically and name a line segment specifically is important in general. So right triangles, which that's all we need to talk about for introductory trigonometry. So we are only going to be talking about right triangles for this Math 10 course. And the defining feature of a right triangle is that it has a right angle. It has one right angle, which is a 90-degree angle. 90 degrees right there. And that's, this little box thing is a conventional way of saying that's a right angle. That's a 90-degree angle. 90-degree angle. 90-degree angle. 90-degree angle. And that just tells us that these two lines are perpendicular. Two perpendicular lines meet at a right angle. But that means we have two non-right angles. So here's, okay, let's name it. Angle ABC, angle ABC. This is angle BAC. We know that these are not right angles. So all right triangles, well, first things first, all triangles contain three angles. Of course, triangles. angle. Tri meaning three. Triangle. So any triangle contains three angles. One angle must be a right angle, a 90-degree angle. Two other angles will be non-right angles. So they have to be just anything other than 90. And just one other kind of fundamental geometry idea is that all three angles will always add up to 180 degrees, 180 degrees. Every single triangle, that is a fact for every single triangle. So that kind of helps us out because at least since this is always 90, that right angle in the right triangle is always 90, we know that these other two angles have to add up to 90. So that 90 plus 90 is 180. The two non-right angles will always add up to 90 degrees because 90 plus 90 equals 180. So one of these, so we can say this 90 is from the right angle, which is always 90 degrees. And then this 90 degrees is coming from the sum of the two non-right angles. So that's like some of the basics. So we've spoken about how we can name line segments A, B, D, E, J, K, J, L. We can name angles based on what's kind of the path I take. Well, oh, for this angle, I'm going BAC to create that angle. So that's how I can name it, BAC, CAB. And then also just discussing how for any right triangle, which is totally what we're focusing on in this trigonometry section, they always have to have a 90-degree angle where those two lines are perpendicular. And then there's always going to be these two other angles. And just because all angles in a triangle will always add up to 180, we always know that the two non-right angles will add up to 90. So that just at the end of the day, our triangle has 180 degrees. So where we get into legitimate trigonometry is where we start to talk about these three sides of any right triangle, and we start to name them, and we give them the names hypotenuse, opposite side, and adjacent side. And here's the thing. The hypotenuse is always the side opposite from the right angle, which is the longest side. So here we go. Here's my little triangle. This is my right angle, right? We just spoke about how right angles are 90-degree angles, and this little box tells me that's my right angle. A right angle happens when two lines are perpendicular. So if the hypotenuse is always the side that's opposite from the right angle, I mean, like, if you were like shrunk yourself down and you were viewing the triangle from that perspective of that 90-degree angle, opposite to that is the hypotenuse, this longest side. So it's always going to be that kind of diagonal or slanted side. And that's always the longest side. And hopefully we know about hypotenuse from Pythagorean theorem. But that doesn't change. Like, that's always going to be the hypotenuse. But the thing about opposite and adjacent side, which is a little bit different, is that it always depends on which angle we are kind of focusing on right now. So the opposite side and the adjacent side are defined relative to one of the non-right angles. So we just talked about how we have two non-right angles. So two non-right angles in any right triangle So just to kind of recap, let's call this one angle ABC and call this one angle BAC. So if we view the triangle from angle ABC as our reference point, I actually like to draw in that little eyeball just for the sake of explaining it. But if I view the triangle from the perspective of angle ABC, and I imagine shrinking myself down and standing right there, this side is the opposite side. Because see how if I was standing right there and facing away from the angle, I would be looking directly at this side, AC. And so that's why I call that the opposite side. And then this other side, if I were standing there and looking forward towards the opposite side, this side would be next to me. And another word for next is adjacent. Adjacent. So BC is my adjacent side, but that's only from the perspective of angle ABC. So from this angle right here, then this is my opposite and this side is my adjacent, but it could be different. Let's focus on angle BAC. So if I go to this perspective and I'm standing there at that angle and I'm looking out, now this is opposite to me. This side is opposite to me because that's what I'm facing. It's like you're sitting at the dinner date and there's you and this side is what's opposite to you. This side is more so what's next to you, right? It's not actually opposite to you, it's more next to you, which is why that's the adjacent side. So that's what I'm trying to explain here is like the hypotenuse is always going to be this side, no questions asked. It's always going to be that side, which is opposite to the right angle, the longest side. But for the labels of opposite and adjacent, it actually matters where am I viewing the triangle from, or what's my reference point? Which of these angles is my reference point? So that's kind of what I mean by that. So let's just try that out in some other examples. So here, and the text on the side here is just exactly the same as what I was just showing you. So this, of course, is that right angle. So then I have my two non-right angles. Angle DEF and angle EFD. And I already know if I'm trying to label hypotenuse, opposite side, adjacent side, well, I know this one has to be the hypotenuse because it's opposite the 90-degree or right angle, and it's also the longest side. And if you've dealt with Pythagorean theorem before, you hopefully know that this is just always the hypotenuse. But then to label opposite and adjacent, it depends. Am I viewing the triangle using the reference point of angle DEF? Or am I using the reference point of angle EFD? So let's just go with this as my reference point for now. So if I shrink myself down and I'm just standing right in that little angle and I'm looking out, this is what I'm facing. This is the side that's opposite to me. And this side is what's adjacent or next to me. So from the perspective of this angle, that's my opposite, that's my adjacent. But from the perspective of angle EFD, again, if that eyeball's looking out, what's opposite to it? Oh, well, it's actually this side. And what's adjacent, air quotes, to it, or to that little viewer, it's going to be this side. So depending on which reference point, which of the non-right angles, you get a different label, or you're considering a different side as the opposite or as the adjacent. Let's just say, let's view this triangle from the perspective of angle GHI. Angle GHI. Well, if that's a little person looking out into the distance, this is the opposite side. This is the side that is adjacent to that little person. This is always the hypotenuse because it's the longest side, it's opposite to the right angle, it's that slanted side that's just kind of recognizable in some way. So I think that kind of does it for that.